Okay, so today we're going to start practicing, I should say reviewing with the quadratic formula. So the quadratic formula is something we should of course have memorized. What is the quadratic formula?
Negative
So,
b.
I hear negative b, good.
Plus or minus the square root of b squared minus 4ac all over 2a.
Okay, so, like a couple of us already had that down from last year.
Yeah.
Everybody else needs to get that down. I don't know if Mr. Fisher's silly song got it to you or what. Well, apparently it was effective despite the silliness. So, that's good. Cool. So that's the quadratic formula. What's more important than memorizing the formula is, of course, how to use it and like what it does. Because it does quite a lot of different things. Where does it come from? We're going to see that on Monday. Okay, so I'll show you where it came from even though you didn't do that last year. Now we should be able to see where it comes from. There's lots of different ways to derive it. I think the easiest one is using completing the square. So we already know how to do that. All right, anyway, we'll look at that on Monday. So remember, the quadratic formula is one way to get zeros. It pumps them out. It says the zeros, x, are these. Except these look ugly, so you have to simplify. But the ultimate thing you need to understand is you plug the stuff in and it pumps out the zeros for you. Does that make sense? It pumps out the zeros, the x's. That's why it says x equals. We okay on that? All right, this inside is going to be important later. That's called the discriminant, b squared minus 4ac. We'll talk about that on Monday too. Okay, so using the quadratic formula, let's see what happens. So we want to find the zeros of f, g, and h. We're going to use the formula instead of factoring or anything else. So, find zeros, you of course set it to 0. We could try to factor this guy. Maybe it factors, maybe it doesn't. Once we use the quadratic formula, looking at the answers, we should be able to say, hey, would it have factored? Or would it not have? Would we have been wasting our time? Okay? So here we go. And by the way, this isn't a new thing either. This is from 2,000 plus years ago. So it's old. The cubic formula, though, is from the Renaissance. You guys are going to read about that next week. It took people a lot longer to figure it out. Anyway, all right. So x equals, what's this ABC jazz? So what's a here? 2. It's the coefficient on x squared. I should never see x's in here. X is the answer that comes out. It's not the numbers that you put in. Okay? So A is 2. B is negative 16. And C is 27. You can write that down every time if you like. It's up to you. So I'm going to say negative B is, I'm going to be putting some color in here, is negative 16. Plus or minus B squared is negative 16 squared. You know, since that's a squared, though, you really never even need to put the negative in here, because what's squared do to negatives? This number's always, every time, going to be positive. That's up to you. Minus 4. There's always minus 4. And then A is 2 for us. And C is 27 for us. And we've got 2A. That's 2 times 2 is 4. How much work you show is up to you on these, but if you're making mistakes, you need to show more. So, this is 16 plus or minus, ooh, I don't know, 16 squared. 15 squared is 225, 256. Yep. Nice. 8 times 27. You should always be real careful right here. This is one place people make mistakes a lot. There's 2 places, that's one. They usually, well, a lot of people make mistakes right here because they don't count their negatives carefully. How many do we have? 1, so it's going to be negative, yeah? Then you just multiply this however you like. 8 times 27 is 216. Thanks, guys. Over 4. So then we're going to have 16 plus or minus. You do order of operations, says like go inside stuff first, right? So it's going to be 40. I don't really need a long one anymore. And here's the other place people make mistakes usually, is they go like this. Something like this. Oh, here, I'll do 2 things that are bad. So they might go like this. What's wrong with that? Some of you are going to do it if you're not careful. Why is that not correct? Is 16 okay? I mean, excuse me, is 4 okay? Yes. Is this okay? No, because it's supposed to be divided by 4. Exactly. So I'd have to put a 4 underneath there still, right? So that's one big mistake, is not actually using the 4 for both pieces. It's a common denominator. They both got to be divided by it, okay? That's one mistake. Here's another mistake. Now they were thinking, okay, they put the 4 underneath both of them, right? 16 over 4 is 4, okay. Square root of 40 over 4 is square root of 10, right? No, the square root of 40 over 4 like that is the square root of 10, but that requires the 4 to be inside the square root. You have a 4 not inside, but outside. So if you wanted to do it that way, you'd have to pass the 4 inside the square root. If you wanted to pass it inside the square root, it wouldn't be 4. What would it be? You guys haven't done that before, but you can. It'd be 16. Because the square root of 16 is 4. That's how you'd have to do that. We're not going to do that. That's not the way you do that when you start out with things. That requires more cleverness, right? So, the way you do this is you say, okay, carefully, I'm going to make sure it's underneath both. So 16 over 4 plus or minus square root of 40 over 4. That's a step I would show, because if you don't, most likely you're going to make mistakes. Yes, this is 4. How do I do the square root of 40? That's 2 root 10. Because 40 is 4 times 10. And the square root of 4 is 2, and the square root of 10 is the square root of 10. That's not going anywhere. And now I've got my 4. So the final answer here is 4 plus or minus root 10 over 2, or 1/2 root 10. You could write it that way as well. Okay? Would this guy have factored if we had tried back at the beginning to factor it? The answer is no, because that's an irrational thing. Stuff that's irrational does not factor. Okay? So we'd have been wasting our time if we'd have tried the little triangle longer factoring process. Okay? So there we go. There's our first quadratic formula example. The last thing I want you to do is get the decimal approximations on this. So I want you guys, when you get something like this, if it doesn't have I in it, I want you to go to your calculator and write down the decimals. So we're going to say 4 plus 1/2. So you can write 1/2 as a decimal, right? That's the way I'd do this guy. Square root of 10. There's one answer. And be quick. If you hit second entry, your calculator types it in again. Minus. Bam. If you didn't see the 0.5 thing, then do it the long way. 4 plus, you can go alpha y equals square root of 10 over 2. There's that same answer, and you could hit second entry and get the other one. This should be really fast. Shouldn't take you a long time. So our answers are 5.581 and 2.419. Okay, there's one quadratic formula problem. Let's do another. What do you guys think? Second one. Does it factor? Before we go to the business of the long quadratic formula. Yes. That's a perfect trinomial. You see it? It's already perfect. X minus 2, x minus 2. How many zeros are there going to be? Just one of x equals 2. Let's see if the formula gives us that. So here we go. X equals negative b is 4 negative negative. Plus or minus the square root of negative b squared minus 4 times a times c. All over 2a. So we've got 16. 1 minus is minus. 4 times 4 is 16. What's 16 minus 16? 0. Ooh, so this okay, so 4 plus or minus nothing is nothing, right? So it's just going to be 4 over 2, which is 2. How many zeros do we get? Just 1. So when you get this inside of the quadratic formula, to be 0, that's when you're going to get 1, 0, because you're going to have plus or minus nothing. The plus or minus part is what gives you two separate answers. And that's what leads to parabolas like this one, where you just have 1, 0. And is this parabola facing up or down, guys? That says it's facing up. When you have 1, 0, that 0 is also the vertex. So that's what we're going to talk more about on Monday. All right? So let's look at the last one, h of x. So we could try to factor it. Let's just do the formula one more time. So this time we're going to go, let's see, x equals negative, what's different?
It's not in order.
It's not in order, and see, you're going to mess up A, B, and C if you're not real careful. Then you probably want to put it in order. It was minus x plus 2, right? Careful about that. So negative b is negative, negative 1. All the examples I picked today had a negative b already. They don't always, though. Plus or minus b squared minus 4ac 2a. So it's going to be 1 plus or minus 1. All these had that too, so that's 16 over 4. 1 plus or minus the square root of a negative 15. Square root of a negative number. What's that? I learned it yesterday. That is I. 15 can't be reduced. So that's about as simple as you can do it. I want you to write it like this, though. 1/4 plus or minus the square root of 15/4 I. So if we go back to yesterday, I don't think it's possible for i's ever to come by themselves. And as you start working in this assignment, you're going to see that. I's always have a partner. Here we've got plus or minus, and this is the thing on I. I's always have a partner. So let me give you some examples. So what if we said we had 2 plus 3i? What if that was one answer for a parabolic equation? What if it was 5 minus 8i? What if it was just 7i? Anytime you're working with a parabola, if you get I, you should get its married partner as well. We call that its conjugate. So let's write that down. Complex roots always have a conjugate partner. That conjugate thing is going to come up again and again if you start doing more math. See it a couple times more this year. It's all over calculus. This is the first time, maybe. So, what do you guys think the partner is for 2 plus 3i? It's not hard to guess it. 2 minus 3i, yes. What do you guys think the partner is if you were working the quadratic formula or completing the square or whatever, and you got 5 minus 8i? What's the other answer? It's 5 plus 8i. You were working the quadratic formula or square rooting or whatever you're doing, and you got 7i, you're going to get negative 7i too. In parabolas, that's a side effect of the plus or minus, but this conjugate idea is a big one. How about this one here? I'm going to be a little trickier. What's the conjugate of that? Is it plus 8? Is it minus I root 91? Yeah. So if you did this, you'd want to write it in its complex form first. Turn it around in your head or on paper. And realize it's really that. So it's going to be, the conjugate is negative 8 minus I root 91. It's that thing attached to the I which makes conjugates in complex land. I'll see you next time.